Hello and welcome to this quick summary of our poster on sampling influential Twitter follower networks. We are Luca Rossi, Associate Professor at the IT University of Copenhagen, and me, Felix Victor Münch, postdoc at the Leibniz Institute for Media Research in Hamburg. I will walk you through the objective of this research, outline the gist of the sampling strategy we came up with, then give you a taste of our preliminary results of its evaluation, and, as always, finish with our conclusions, limitations, and what we plan to do next. Actually, our method is already available for you to do your own Twitter samples. The link is in the summary on top of the poster. Our original goal was to map the German-Italian Twitter sphere and to evaluate the method that we designed to do so. Today we are talking about the method and its evaluation. Most research on national Twitter follower networks collected the full network, but filters the network for highly central nodes before analysis. Especially due to recently tightened restrictions of the Twitter API, we thought it might be worth trying to only collect those nodes in the first place. Therefore, we lean on the rank degree method described by Salamanos et al. Simplified, it is based on walkers which iteratively walk to the neighbor with the highest degree and added together with the walked edge to the sample. In tests by Salamanos et al., it showed good results in quickly collecting the most central nodes of undirected networks. Therefore, we further developed it to meet requirements dictated by the nature of Twitter follower networks and the limitations of the Twitter API. Most importantly, the original method necessitates knowledge of all nodes in the network. As this data is not available, we only start with a few random starting nodes and collect the seed pool on the go. We call this process bootstrapping. Furthermore, the sample quality improves greatly if we densify the sample after the sampling process with all edges that exist in the original graph between the sampled nodes. We test our method on a known network of the same kind as our networks of interest, the full Australian Twitter follower network. It consists of almost 3 million nodes and 166 million edges. After a test run with 100 walkers walking 10,000 steps, we got a sample with about 10% of its nodes and roughly 20% of its edges. While the shape of the degree distributions of sample and original resemble each other, our method is biased by design. It prioritizes higher degree and, as we will see, higher K-core nodes. So it's not surprising that the degree distributions do not pass a Kolmogorov-Smirnov test. However, interestingly, neither does a random node sample with the same number of nodes or a random edge sample with the same number of edges. The main takeaway here is on the upper left. The higher the K-core of the original, the smaller the fraction of nodes we lose in the sample, in a linear fashion. Personally, I find that interesting because this nice behavior is somewhere in between a random node sample and a random edge sample with a comparable number of nodes. However, the most surprising result is that we reach a pretty good rank correlation of 0.9 regarding K-corness. Not even a random sample with the same number of edges, which comprises 80% of the original nodes, reaches that value. In summary, these first results let us conclude that the method fulfills our goals, even though it's worth thinking about possible tweaks which, for example, improve the bias towards high K-cores or make the algorithm more efficient with the Twitter API. That's it. I hope you've enjoyed the summary, and if it could spark your interest, please have a closer look at our poster and ask us anything during the Q&A session, in the comments, or on other channels such as Twitter.